In this next video, we are going to look at one-sided limits, which is an AP exam favorite. And here's where the AP exam gets clever. It doesn't just test a regular limit, it tests whether the function approaches the same value from the left and from the right. Look at what we have on the screen. From the previous video, you had this limit notation, except we didn't have these small subnotations that you can see up here. So what did this mean? Let's start with the little minus. The little minus means approaching from the left. And another way to think about it is approaching from x values less than 2. And then on the right hand side, the plus sign means approaching from the right or approaching from values greater than 2. You can choose whichever makes more sense to you to remember and just stick with it. They both mean the same thing pretty much. So this one is approaching from the right or x values greater than 2. So remember from the previous video how you read the limit notation. So this one is basically asking you, what is the limit as x approaches to from the left-hand side of f of x? What is the limit as x approaches to from values less than 2 of f of x? And then on the right-hand side, this one is, what is the limit as x approaches to from the right-hand side of f of x, or the other way, what is the limit as x approaches to from values greater than 2 of f of x? How does this tie into the actual limit? So, a limit exists if and only if the left-hand limit and right-hand limit are equal. Notation-wise, this is what it means. The limit as x approaches a of f of x is equal to L. IFF just means if and only if. It's a math notation that's used, so don't worry about that. So the limit as x approaches a of f of x equal to L, and this is essentially saying the limit as x approaches a exists if and only if the limit as x approaches a from the left-hand side equals the limit as x approaches a from the right side, and they both equal a definite number L. So if and only if this is true is when we'll have the limit as x approaches a. So you have to look at both a approaching from the left and a approaching from the right to determine if you have the limit as x approaches a of f of x. Let's look at an example for this to make more sense instead of just looking at notations. So here we have two functions, the first function f of x and the second function g of x, and we need to find the limit as x approaches to for f of x. Let's start with that. So this question is asking you to find the limit as x approaches to of f of x. In order to figure out what that is, we have to figure out the limit as x approaches to from the left-hand side of f of x and the limit as x approaches to from the right-hand side of f of x, and check if these two are equal. If they're equal, then we do have a limit as x approaches to. Let's start with this first one, the limit as x approaches to from the left-hand side of f of x. So as we are approaching to from the left-hand side, we see that the y values get closer and closer and closer to around 4. So as the x values get closer and closer and closer to 2, we are getting closer and closer to 4. The function is getting closer and closer to 4, the y values. So here we can conclude that the limit as x approaches 2 from the left-hand side is 4. Let's look at the limit as x approaches 2 from the right-hand side. As the x values get closer and closer to 2, again, we see that the y values are getting closer and closer and closer to 4. Which means that the limit as x approaches 2 will be 4, and this is because the left-hand side limit and the right-hand side limit are equal to each other. So here, this limit will be 4. Let's look at the limit as x approaches 2 of g of x. So here, we have a function, g of x. So in order to find the limit as x approaches 2 of g of x, we have to find the limit as x approaches 2 from the left-hand side of g of x and the limit as x approaches 2 from the right-hand side of g of x, and check if they're equal. Let's start with the left-hand side. Let's figure this out. So the limit as x approaches 2 from the left-hand side, as we are approaching 2 from the left-hand side or from values that are less than 2, you can see that our y values are growing and growing and growing towards 2. They don't get to 2 because 2 is not defined here, but we care about the journey, so they're getting closer and closer and closer and closer to 2. And then on this other side, let's figure out the limit as x approaches 2 from the right-hand side. So as the x values are approaching from values greater than 2 from the right-hand side, we can see that the y values grow and grow and grow and grow. And they're approaching, I think, around 4.5-ish. So when we approach this from the right, you get around 4.5. So the limit as x approaches 2 from the left is 2. And the limit as x approaches 2 from the right is 4.5. They are not equal, which means this limit does not exist. So here, the limit, where is that? As x approaches 2 from the left-hand side of g of x is not equal to the limit as x approaches 2 from the right-hand side of g of x. So the limit as x approaches 2 of g of x does not exist, which you can just represent as DNE, just stands from does not exist. I hope this makes sense. See you in the next video.